In this video, we're going to take a look at scientific notation. Scientific notation, we're going to look at converting into scientific notation, so going from standard notation to scientific notation, and then going from scientific notation back to standard notation. So just as a basic introduction, let's make sure you know what scientific and standard notation are. So scientific notation is going to look like this number right here. Scientific notation is when you want to shorten a very long number into a smaller number using times 10 and then an exponent right here. So you can see this example. This number at the top, which represents actually 1 mole, we'll get into moles in chemistry here pretty soon. 1 mole right here, this is written in regular or standard notation. So standard notation is when it's all written out. And you can see, would you really want to write out a number that large? Probably not. That would take forever and it would take up your entire paper and you just wouldn't want to do that. So what you do is you convert it into a smaller number that means the same thing. So you go from 602 decillion, is what that number is called, has 21 zeros, and you convert it to 6.02 times 10 to the 23rd. Now, that is just the basic standard notation, regular notation. Now let's get into a little bit of the rules in terms of how we convert to standard and regular notation, because you can see down here, I actually have a negative exponent right there. I have a positive exponent up here. So, and you see this number is less than 1, and this number is much, much bigger than 1. So how does that all work? Well, for any number that is greater than 1, so we're starting any number when we're looking at its standard notation, so this type of number right here, it's standard notation. For any number that is greater than 1, it will always end up with a positive exponent. So this is 602 decillion. It ends up with a positive exponent of 23. Any number that is less than 1 will always have a negative exponent. So you see, we start with 0.0000592. We end up with a negative exponent of -5. So those are the two most important rules. Numbers greater than 1 will always have a positive exponent. Numbers less than 1 will always have a negative exponent. And then just a side note, sometimes on a calculator, if you're typing this in, you'll see like 6.02 E2. That just means the E just represents times 10. So you could just like sub out times 10 and just write E. That's just a fun fact for you to look at on your calculator. But make sure you got these two rules and the two examples that go with it. Numbers greater than 1 like this will always have a positive exponent. Numbers less than 1 like this will always end up with a negative exponent. Now we're going to get into how you actually do these conversions. So first, we're going to do processes for converting to scientific notation. So going from a big number like this or a small number like this into a more compact number like that. So we're going from standard notation to scientific notation. These are just the 4 rules. You can just take these down. I'll go through them quickly so you can pause if you need to. First, you identify if the number is greater or less than 1. If it's greater than 1, like 602 decillion, you know you're going to end up with a positive exponent. If it's less than 1, you know you're going to end up with a negative exponent. Then you move the decimal so that it falls between the first 2 non-zero digits. However many times you move that decimal, that is your exponent. For example, so I said you move the decimal until it's between the first 2 non-zero digits. So here, we have our decimal right here. We see our number is less than 1, so we know we're going to end up with a negative exponent. And we move it just like this. 1, 2, 3, 4, 5. And I stop right here. These are my first 2 non-zero digits. How many times did I move my decimal? I moved it 5 times. And I ended up right here, which gives me 5.92. See how I did that? Moved the decimal from here between these two numbers, so it gives me 5.92. And then you always put times 10, and then your exponent is however many times you moved the decimal. So in this situation, I moved the decimal 5 times, so my exponent is -5. Why is it negative? Because the number I started with was less than 1. So that's how you determine if it's negative or positive. Then, like I said, you shorten the number by taking away the non-essential zeros. So I moved the decimal, so I got rid of all these zeros. And add times 10 plus the exponent. So I moved it 5 times, so I add times 10 to the -5th. So that's how you convert to scientific notation. Take those rules down, maybe do another practice problem like this, and we're going to do some practice problems right here that I will go through with you. If you can pause and do these on your own, do that and then check your work. If I do 3, and you can do the other 3 on your own. Pause, and then check your work. Okay, converting to scientific notation. So you move the decimal. The first thing you do, this is less than 1, so we know it's going to have a negative exponent. Move the decimal 1, 2, 3 times between my first 2 non-zero digits. So I end up with 4.51 times 10. How many times did I move the decimal? 1, 2, 3 to the negative 3. I don't have I can't make a subscript here, but that should be small and at the top. So that is the first one. Second one, my number is greater than 1, so we know we're going to have a positive exponent. So I move it between my first 2 non-zero digits. 1, 2, 3, right there. So it's going to be 5.6 times 10 to the third. And it's positive because, I'll put a little caret here. It's positive because the original number was greater than 1. Okay, this number, greater than 1, so it's going to have a positive exponent. Let's move our exponent back here between the first 2 numbers. So we'll move it 1, 2, 3, 4, 5, 6, 7 times. Now, in a number this long, you move it 7 times, just put the first 2 numbers. So you would just put 9.0 times 10 to the 7th. Just eliminate all those other non-essential numbers. All right, this time my number is less than 1. So I'll move it 1, 2 times. Right there, I end up with 9.5 times 10. And it's going to be to the negative second because my number was less than 1. Okay, we got 2 more. This decimal, I would move 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So we're going to have 1.0 times 10 to the 9th. It's positive because my number was greater than 1. All right, last one here. This is a big one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. My number is less than 1, so it's going to be 1.9 times 10 to the negative 12. Okay, if you have questions about those, go back and check and see how I did them. Basically, it's just identifying if it's positive or above 1 or less than 1, and then moving the decimal between those first 2 numbers, and then you're good. Then you're just adding 10 times 10 to whatever power based on how many times you move the decimal. So that is converting to scientific notation. Now quickly, converting from scientific notation. So that means you are going from, we're reversing it, so you're going from this, you're going to see this, and you're going back to this. So we're going in reverse. First, you identify the exponent. Is it positive or negative? So like here, I would see it's 3, so my exponent's positive. If the number is positive, then the final number must end up greater than 1, because you're going in reverse. If the number is negative, then your final number must end up being less than 1. For example, my exponent here would be positive. It'd be 3. I'd have to end up with 5,600. That is greater than 1. My exponent here is negative 2. I would end up with 0.095. That is less than 1. Move the decimal based on the exponent. Example, if the exponent is 4, you would move the decimal 4 times. And you move it in the direction that will either make it a number bigger than 1 or a number less than 1. Typically, that is what you will do. Then check. If your exponent was negative, make sure your final number is less than 1. And then if it was positive, make sure your final number was greater than 1. Okay, here's some examples. 1.94 times 10 to the 5th. First thing you do, identify if this is positive or negative. It is positive. What does that mean? My number must end up greater than 1. So I'm just going to move this, and I move it however many times my exponent says. So 5. Now, if I need a number greater than 1, should I move it this direction or should I move it this direction? Well, my number is getting bigger if I move it this direction, so I need a number greater than 1, so I need to move it this direction. So I move it 5 times. 1, 2, 3, 4, 5. Now, you wonder, what do you put right here? In all these little, I just call them little cubbies, little U's right here, when you move the decimal, you just add zeros wherever you can. So that would end up being 1, 9, 4, and then 3, zeros. 194,000. My exponent was positive. I end up with a number greater than 1. Okay, this one. Pause this and do these on your own if you think you can. My exponent is greater than 1. I have to move it 3 times. If it's greater than 1, do I move it this way or this way? I want to move it this way. 1, 2, 3. Right there. So I just have to add 1 0 right there. So I end up with 2,550. Just moved it 3 times. My number needed to end up greater than 1, so I had to move it this direction. All right, finally, we have a negative exponent. I have 1.4 times 10 to the negative 2. It means I'm going to move it 2 times, but which direction? If I move it this way, is my number going to end up greater than 1 or less than 1? It'll be greater. I need it to be less than 1, so I need to move it this way. 1, 2. Decimal right there. Add a 0, so you end up with 0.014 for your answer there. If you haven't yet, pause it and try to do the last 3. Okay, negative 8. That means I need to move it 8 times. I need to make it a number less than 1. So I'm going to want to move it this direction. It's going to make my number less than 1. I'll move it 1, 2, 3, 4, 5, 6, 7, 8 times. Sorry, that was really crammed in there. If I move it 8 times, I end up with 7 zeros. So it'd be 1, 2, 3, 4, 5, 6, 7, 4, 8, 5, 5. So that is a number less than 1, so that is successful. This one, another number less than 1, 10 to the negative 6. So I'm going to move it 6 times. I want to make the number less than 1, so I'll move it 1, 2, 3, 4, 5, 6 that way. Sorry, I ran out of room again. I would end up with 5 zeros, so it would be 1, 2, 3, 4, 5, 7, 0, 0. Number less than 1. And my last one, 11. It's a positive number, so I need my end number to be greater than 1. So I'm going to move this 11 times this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What that ends up being, it ends up going 1 and then 10 zeros afterwards. So it'll be 9, 9, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that number ended up greater than 1, and that is because I had a positive exponent. So that is scientific notation, converting to and converting from scientific and standard notation, or regular notation, same thing. We're going to do a lot more practice with this, but I will let you go for now. Farewell and good luck.